Good morning and welcome back to our channel. So we will be discussing the Wallis Formula. But before the Wallis Formula, I have to introduce solving a problem where Wallis Formula can also be applied later. Para ma-appreciate rin naman natin paano pag ang Wallis Formula ay hindi natin alam. So we were able to solve a problem. So this is also a way of recalling the trigo transformation wherein we have powers of sine and cosine. Now we notice that the powers of sine and cosine are all even. So we have to apply the power reducing formula for sine and cosine. So this is the transformation to be made. So replacing the sine squared with 1 minus the cosine, double the angle here. So if this is x, so I can make it 2x. So this is all over 2. When it is cosine squared, so it is 1 plus. So instead of having minus for the sine squared, I can have 1 plus a cosine also of a double angle over 2. This is to the fourth power. That is why outside there is an exponent 2. Now you have to multiply these two factors. And if I'm going to expand this binomial, I will arrive with a perfect square trinomial wherein later can be multiplied with another binomial. Now, in order to control the number of terms appearing on the product, so instead of expanding the binomial, so I choose to multiply the two conjugate factors. We have 1 minus cosine 2x with 1 plus the cosine 2x so that the product of this will only be composed of two terms, wherein later, I can multiply with the remaining factor 1 plus cosine 2x. Okay, so you may have your own style on how to expand your or to get the product of this, but in my case, this is what I did. So I can now distribute. Okay, I have 1 with the cosine 2x, then I have 1 minus cosine squared, and this is minus cube of a cosine. So these are terms where the first and second terms are already integrable. The third term, so needs further transformation under the same case. Now, wherein we still have the even power of a cosine. So I can again apply replacing my cosine squared with 1 half plus 1 half of the cosine. Double the angle 2x, it becomes 4x. So this is now the replacement of the cosine squared of, so the square of the cosine 2x. This is preceded with negative. I can combine 1 and the negative 1 half, so I have 1 half. I have a cosine 2x, so these two are integrable. This is minus cosine or 1 half of a cosine of 4x, so these three are already integrable. The last term, which is in cube, so will be transform further under and add power for cosine. So I can have a cosine 2x be expressed as a factor and the remaining cosine squared will be replaced with a Pythagorean identity. 1 minus cosine squared minus 1 minus sine squared is equivalent to a cosine squared. So there I can again distribute, or maybe I can have the integral of the terms which are already integrable like 1 half. Okay, so 1 half and 1/8 if you multiply, so you can do integration. So the integral of which is 1 over 16 of x. No? Now this one, the cosine 2x, if I have to do the integration, so take note that there's 1/8 before. So it's 1/8 integral with cosine 2x dx. So I need to insert 2 and neutralize with 1 half. That is why we have 1 over 16. That's the product of 1/8 and the neutralizing factor in order to integrate the cosine 2x to dx. So we have the sine 2x as its integral. Now this one, this is negative 1 over 16, correct? 1 over 16 as I distribute my 1/8. Inserting 4 and neutralize with 1/4, then I have 1 over 64. The integral of cosine 4x for dx is sine of 4x. Now, I'm now with a term which is still not integrable and needs further transformation. This is 1 over 8, and if that is distributed, so we have a cosine 2x dx for my first term, and the second term is 1/8, that is positive, correct? So that is positive 1/8, the integral of sine squared with a cosine 2x. So, if we have to check with our u and a du form, our u here is the sine 2x, the du of which is the cosine 2x to dx. So this is lacking with 2, correct? And neutralized with 1/2 here. So I already have the 1 over 16 now before this functions, no? Or we have to do the integration under a power rule. So if we increase the power of sine to 3 and that becomes sine cube, then that is divided with 3. 3 times 16 is, so that is why we have 1 over 48. I notice that there are terms which are exactly opposite. So, these two are eliminated. So, what is left is only the 1 over 16 x minus 1 over 64 sine of 4x plus the 1/4 of the cube of sine 2x, now with limits of 0 to pi over 2. Now, when upper limit is substituted, okay, so there I have the terms. So, pi over 2 is replaced to the variable x, okay? So, that is the substitution. When 0 is substituted for all the terms here, you will notice that the terms here will always will come out to be 0. Okay? So, this is the only terms, or these are the only terms which will produce the function value. But the 2 pi, the 2 times pi over 2, or simply pi, the sign of which is also 0. The sign of 2 pi is also 0. Correct? Okay. So, the value will come out as pi over 32. And the pi over 32 is our answer. So, that is how lengthy the process is, no? When we have to go with the transformation before we can solve this by using, or we can solve this as a definite integral. But this can also be avoided because we also know that by this time, calculator can be used to solve any definite integral, no? So, before, si Wallis, medyo sa sikat, no? Pero karon medyo nakuha agamay because as an alternate, a calculator can also be used to solve for a definite integral in a form like this, no? Now, before, when Wallis ramo ay sikat, so this is how to use the Wallis formula, and this is the Wallis formula, which is applicable to a form where we have a product of sine and cosine raised to a power correspondingly m and n, where m and n are non-negative integers. Limits, by the way, must be observed. The limits must be from 0 to pi over 2. And if this is x, that is x, so that must be dx. So if this is u, this is u. This must be du in order to use the formula. The factors appearing in the numerator of a ratio will be taken from the power of sine. So if m is the power of sine, so the first factor is m minus 1 and successively decrease by 2 in every factor. That is why if you have m minus 1, the next factor is m minus 3, m minus 5 until we reach a factor which could be 1 or 2. 1 or 2. So, imo hang ihunong, no? Then we can consider the other factor coming from the power of cosine. Still the same, you reduce the power of your cosine by 1 and successively decrease by 2 in every factor until you reach a factor which is 2 or 1. Then it's divided with the sum of this power. So, m plus n as my first factor. Then the next factor is to reduce the first factor by 2 successively until you reach also 2 or 1. It's multiplied with alpha, and alpha has 2 possible values. So, you can use pi over 2 if both m and n are even. 0 is also considered as even. So, if 1 will be used, so that is only cases which is there is maybe a power here which is even, which is odd, or both are odd, so you can use a value 1 for the power for the value of your alpha. Okay, so let's try working with the previous example we have. So we will be solving using a Wallis formula now. So we have sine squared multiplied with the cosine to the 4th power. Check with the angle. This is x, that is x, so that's dx. Limits is from 0 to pi over 2. So, it makes your Wallis applicable because all conditions are there. Limits must be 0 to pi over 2. Powers must all be integer, and none of which will be a negative integer. Okay, so to use your Wallis formula, so this is what we're going to do. Consider the power of sine. The power of sine is only 2. So, if you subtract 2 by 1, so this is the factor considered. You arrive with the factor which is 1. Since it is 1, then you have to stop immediately. Then you can consider the other exponent. Again, you can decrease 4 by 1. So, you can start with 3. And if you subtract 3 by 2, then you also arrive with 1. So, these are the only factors which can be placed in the numerator of your formula. In the denominator, it is the sum of 2 and 4 which will be your first factor. So 2 plus 4 will give you 6 as the first factor, then minus 2, so that's why we have 4. 4 minus 2, then you have 2, and that is the last factor. You have to multiply with alpha. Alpha must be pi over 2 because both are even. Okay, then you have to simplify. So maybe we can divide, no? So since this is a ratio, then we can reduce the lowest term by removing a common factor. Just like 3, if this is out, so there is 2 left in the factor 6. So 2 times 4 times 2, then times another 2. So we have 8 times 4, that's 32. That is why we have pi over 32. Now you can also easily reduce this also in a lowest term by having this place be placed in your calculator and perform the operation, and the calculator will reduce by itself. You may not include the pi factor, so you can just go with this constant. Then that will reduce to 1 over 32. Then just multiply that with pi as your final answer. As more example, I have this. With the same limit, 0 to pi over 2, my sine is raised to power 8, and my cosine is raised to power 7. All powers are integers. One is even, the other is odd. Okay, so let's try with the application of the formula. From power of sine, which is 8, I can start with what factor? 7. Because it should be 1 lower than its power. That is e minus 1. So you can start with 7. And once you have 7, then 7 minus 2, there you have 5. Then 5 minus 2, there you have 3. 3 minus 2, then you have 1. And this is the last factor because you have to stop with a factor which could be 2 or 1. Then consider the exponent of cosine, correct? So this is 7, so I have to start with, okay, that's in minus 1. So 7 minus 1, 6, 6. Then 6 minus 2, there you have 4. 4 minus 2, then you have 2. So this is the last factor. It should be closed with a, or you may close with a bracket, no? So, okay, so then we can go to the denominator. The denominator is their sum, being your first factor. Then decrease by 2. 15 minus 2, 13. 13 minus 2, 11. 11 minus 2, 9. Then 7, 5, 3. Then 1. Obviously, I can remove 7, 5, 3. Okay? So, what is left? 6 times 4 times 2 divided by these factors. Okay? Then you will arrive with a ratio that is already in lowest term. I used 1. Why? Because 7 is odd. And if there is odd power, or both are odd, then you will be using 1 for your alpha. So that's how to answer and by using a Wallis formula. So makita ni mo nga, kung gamit kag Wallis formula, so medyo sa yon pagkuha sa imuhang answer. So even the use of calculator, no, maunahan pa na sa Wallis formula because sometimes it takes time to process, no, in order to arrive with the value with the use of calculator. So try to learn the Wallis formula. Number 3 as additional example. So sine does not appear because sine has a power of 0. If 0 is the exponent in any of the factor of sine and cosine, 0 is considered as even. So if 0 is even, then both powers are even, so you can use pi over 2 for your alpha. Okay, the Wallis formula is applied in our solution. So I can start with 5 as my first factor in the numerator. 5 minus 2 is 3. 3 minus 2 is 1. Then I go down, it is 6 plus 0. So that's why we have 6, 4, then 2. So alpha is pi over 2 because both powers are even. What are the exponent of cosine and sine? So cosine has a power of 6, sine has a power of 0, and 0 is an even number. So this is multiplied, divided, and simplified. So we can remove again 3. This is 2 times 2 times 2 times 4. Then, this is 32. So, we have 5 pi over 32 as the answer. So, this is different. If you look at the given, Wallis is no longer applicable. Why? Because the limit is equal to 0 to pi over 6. This is actually not the limit which is 0 to pi over 2. So, Wallis is not possible to use under this case. Angle is 3x. That's 3x. Well, this is dx. So again, dili magamit imong Wallis because if this is 3x, this must be 3dx because it should follow also the u-du form, just like in the formula of integration. Now, I have to modify in a way that if possible, I have to use the Wallis formula. Now, is there a possibility of using the Wallis? These are values of x. If this is a value of x and you substitute here, 3 times 0 remains to be 0. If we will be calling 3x being our u, so your u can be 0, correct? If your u is 3x and your x is pi over 6, is there a possibility of arriving with a value of u which is pi over 2? So, it is 3 times pi over 6 is pi over 2. So, there is a chances of having a Wallis formula be applicable. Okay, so you have to start with substitution. So, when you transform, so, the 3x is considered as our u. The du of which is 3dx. So, if I'm going to replace my 3x with u, so 3x with u, then dx will also be changed in terms of u. Dx is produced when we divide by 3 both sides. So, du over 3 is your dx. Now, if we will be changing the variables, then we will also be changing the limits. So, if u is equal to 3x, so same as what I stated a while ago. If my x is 0, then my u is 3 times 0 because that's 3 times x, correct? So, it is still 0. If my x is pi over 6 as in the upper limit, and I know that my u is 3x, so 3 times pi over 6 is pi over 2. So, if I'm going to substitute this time in our given, then this is sine cube, my angle is u. This is cosine to power 7 for an angle u also, and dx can now be du over 3. So, this is almost following a Wallis formula. So, the only problem here is the presence of a constant 1/3. There is a rule involving a product of a constant and a function involving the variable of integration. That constant can be placed before. So, that is why 3 or 1/3 can be placed before our integral sign. So, pwede na ka mag-integrate on that case. It is just like having 3 as my u, 3x again as my u, and my du is 3dx. And I'm putting a neutralizing factor of 1/3. And the limits can be changed imaginarily from 0 to pi over 2 if you want to shorten your approach of solving. No? So, without showing this anymore. No? So, next. Okay, so I tried to show that Wallis is already followed, okay, with 1/3 before my Wallis application. So, when Wallis is applied, so there is 1/3 and I can consider the power of sign. I can start with 2 and I immediately stop because when you reach 2 or 1 as a factor, then you have to stop. Then 7, what will follow? The first factor of that is 6. And once you have the first factor, decrease it successively by 2. So, 6 minus 2 is 4 and 4 minus 2 is 2. Then you also have to stop. The sum of 3 and 7 is 10. So, that is your first factor. Okay, so 10 minus 2, there you have it. 8 minus 2, so you have 6 then, 4, then stop with 2. Then it's multiplied with alpha. Alpha, try to look at the power of sine and cosine. Both are add, so it means the value of which is 1. So when these are multiplied and reduced to Lewis term, then I arrive with a value of 1 over 120 being my answer. So this is the application of Wallis formula where there is also a transformation needed and a substitution made in order to show clearly that Wallis formula is also applied, can also be applied on that given situation. Now, number 5, I have a limit of 0 to pi over 2. Now, before you transform, always check if there is a possibility of arriving with a limit of 0 to pi over 2. When these are values of x, you substitute to the given angle here. If that is 0, 0 over 2 is still 0. If this is a value of x, so x over 2 or pi over 2 is already on a limit of 0 to pi over 2 when this is replaced with another variable through substitution. Okay, let's try. Transform by substitution. My u is equal to the given angle of x over 2. My du is 1 half of dx, correct? So, my dx is 2 times the du. No? So, dx is 2 du. Since I'll be changing my variable from x to u. Then, I also have to change my limit based on this. My u is equal to x over 2. Now, if x is 0, same as I said ganina, so you will arrive also with u as a 0 value. When x is pi, so pi over 2, so u is also pi, is already pi over 2. Then I can do the substitution, including the changing of limits. Okay. So 0 to pi over 2 as my limit for my u. This is the new limit. Sine raised to power 8. So sine of u raised to 8 because this is x over 2 now replaced with u. The dx is a product of 2 du. Then you can put your constant before. Immediately here, ibutang siyas gawas. Okay? Then, it's 2 with a form where Wallis is already applicable. So, I can now apply my Wallis formula. With 2 before the Wallis formula is applied. So, I can have it as my power. So, I can have 7 as my first factor. So, 7 minus 2. Then, minus 2 again. Minus 2 stop when you have 1. If I have 8 as my first factor, now because if it is only sign that is appearing on the given, it means that the cosine has a power of 0. So, if that's 0, that's even, and I have a sum of 8 and 0. So, I have a denominator of 8, then reduced by 2, reduced by another 2, then you have the last factor which is 2. I'll be using an alpha which is pi over 2 because both are even. When this is simplified, so there I obtain the value 35 pi over 1 to 8 as my answer. Now, number 6, this is medyo lahi, no? With the previous. Looking on the given, limits is from 0 to pi over 2, my angles are not the same. So, there is really a problem here, no? So, we have to consider identity, maybe. Which angle will be preserved? If my x has a value of 0, no problem with the lower limit because these two will remain to be 0, correct? But if I have pi over 4 and b, a value of x, what is the product of 4 times pi over 4? It's not pi over 2 but simply pi, correct? It is pi, I mean. No? If nag-simplify, no? It is pi. So, I cannot make use of the angle 4x with this as the limit. I have to check with 2x. If that is 2 times 0, that is 0. And no problem with that, correct? Okay? Na gawas ang atong tinaguan sa ubos, no? So, gauna-una. Anong sa ning ubos ni kalit magawas, no? Okay, so, correct. If I have 2 times pi over 4, what is the product? That will give you pi over 2. So, what does it mean? In order to use the Wallis formula, the angle here must be expressed in terms of 2x. Now, take note. 4x is twice the value 2x. So, I can relate that with a double angle identity. What identity is that? The sine of a double angle can be taken as factors of 2 sine theta cosine theta. But ipasabot, if my angle is 2x here, so if I have the angle of 2x and 2 sine 2x cosine 2x, then I can double 2x as 4x or 2 times 2x which is 4x. So the sine of 4x is equal to 2 sine of 2x cosine of 2x. So I can replace the sine of 4x with this expression. Okay, so this is from a double angle identity. But take note, this is not sine of 4x alone, but it is a square of sine of 4x. So, I can put this also into square. Okay, so here I have 2 sine 2x, cosine 2x also in square. So, the square of 2 is 4, correct? The square of sine is sine squared. Okay, so there I have the sine squared. And I have the cosine to a power 2. I also have the cosine with power 3. That's why I have a cosine raised to 5th power. So, the angle still 2x and my limit is 0 to pi over 4. So, do not go immediately with Wallis because you still need the transformation similar to the previous two. Okay, so my u is 2x, correct? So what's my du? My du is 2dx. Okay? So if that is 2dx, then my dx from this equation is half of du. Then limits will also be changed. If u is equal to 2x, then I have to change my limits. If these are x values, if x is 0, then my u is 0. And if my x is pi over 4, you substitute 2 times pi over 4 is equal to pi over 2. So you can now substitute including the limits in terms of u na. Okay, so there I have 4. Correct? Then, sine squared u cosine to the 5th power du over 2, and this is limit 0 to pi over 2 because we are already using a variable of u instead of x. No? So, there is a little problem with the du over 2, but 1/2 can be placed before, and I can have a product of 4 and 1/2. Then, the Wallis is applied right here. So, 4 and 2, or 4 divided by 2, so that gives you 2. Now, I can start with 2 with a factor 1. I can have my 5 and my first factor can be 4. Minus 2, then I have to stop when I reach 1 or 2. Then, go with the denominator. It is their sum, which is 7. Minus 2, 5, correct? Then 5 minus 2, we have 3. 3 minus 2, we have 1. And stop, correct? Then alpha must be 1. Why? Because we have an odd exponent in cosine function. So that is 1. When these are multiplied, so we come up with 16 over 105 as our answer. So that's all with the Wallis formula. So I hope that is again another learning you have with our discussion. So I'm happy to see you around always, and padaghanon nato atong mga gasunod sa atong channel, para daghan nig maabot atong mga discussion dire, so sa inyong mga amigo, sa mga nakasubscribe na, so invite them, share this video, share our channel so that they will also come to subscribe. So malipay ta magtan-aw nga magkadaghan atong subscribers. Okay, so encourage me by doing that. So more videos in our YouTube channel to be shared later. Thank you for being around. And good day, everyone.